I assume it's recording. Okay. So we're going to use transformations to describe how the graph of the function is related to a basic trig graph and graph 2 periods of it, if they fit on my piece of graph paper. Okay. So chapter 4, test review day 2. All right, so the only thing that's different here is this little 2 in here, and that means that the period changes. So the normal, when we would have tangent, which is really just not a normal thing anyway, would be taking 2 pi over absolute value of b, because normally the period is 2 pi, but it turns out that our b value is 2, and so we're going to change our period to be pi, because 2 pi over 2 is... It sounds literally like it's going to happen. Yeah, apparently it's like a parent's rite of passage. Anyway, that's great. I'm so glad that you got to play the recorder. Okay. Okay, so traditionally tangent, and let me think, where is it? Here, so half is, I just gotta set myself up a little bit more. Okay, so traditionally tangent would go like this, and sometimes I forget, so I just graph it again on an actual device, and then like this. Oh yeah, so good at dash lines. Okay. But I want to double check because for some reason I can't remember if it goes up at the origin or down. So I'm going to actually get out the regular calculator and not Desmos, as much as I love Desmos. Because of course we got to know how to use the calculator if that's the only thing that's allowed. So we got to be in radian mode, otherwise you're going to have a graph that goes up to 360, which we don't have in our window currently. So tangent of, well, I just want to do tangent of x because I just want the regular one. Ooh, and then I didn't do my window differently. What is my scale on this guy? Pi over 4, actually. So my x is negative 2 pi and 2 pi. And then my scale is pi over 4. All right. So it'll look like mine. Yeah, so it goes up and over. Okay, yeah, that's exactly how I drew it. Sweet. But now the period is going to be just pi. And so instead of being from here to here, which is a length of pi, 2 pi for the period, it's actually going to be only 1, 2, 3, 4 squares, where 2 of these will repeat. I believe it still ends up going through the origin, and so I want to make sure that that's what happens, so we'll put a little 2 in here. Yep. So no matter what's happening to it period-wise, it's still going to go through here. And so now instead of being 4 wide, it's 2 wide. So our asymptotes, if you will, are going to be here. And then here. Tangent is just so ugly, so I don't know how to make this any prettier. So this is pi for the period versus 2 pi. All right. And of course, since you're going to be doing it on a multiple choice calculator, multiple choice test, yeah, you'll just have to know which one happens and not actually have to draw it like this. Lots of things happening here, but the answer is the purple one. And they wanted you to do 2 periods, so I suppose you would take the time to do all the rest of them, because that's only 1 period. Yeah, tangent's not my friend. Okay. Exception to every rule, tangent. Okay. So, ooh, the next one. Oh, P.S. Do you need more time? Because you never know. Have any questions about tangent? Yeah, tangent acts like the x cubed going up there. Okay, so we're going to use transformations to describe, did I need to do this to describe how the graph, oh, I didn't do it over here. I got to type it out. The description, compressing, horizontally to make a period of pi instead of 2 pi. Sweet. I don't have the symbol on my keyboard, so pi is what we're going with. Okay. We'll make it red so people see it. Okay. So this one here, ooh, oh, gross. They have a period that they're changing of pi. That's why it's on a regular 10 by 10 grid, because we actually are taking out the pi from it. So that's weird. Also weird to say that I'm taking out pi. Okay, so 1 over cosecant is sine. So 1 over sine of pi x, which means that your period, instead of being 2 pi, it's going to be 2 pi over our absolute value of b, and our b is pi. And so that means it's 2 pi over pi. And so it just means that the period is 2. So between here and here is going to be 1 entire revolution of sine. Gross. Okay. It's going to be so skinny. Okay, so sine normally goes up at the origin, right? Okay, but this is flip of sine. So let me think about that for a second. Yep, so instead of going up at the origin, it's going to go down. It is going to be a height, because it always is an altitude of 1. So we only, oh my God, we're going to be in this tiny little box. I'm so glad that we have that tiny box for where we're going to have this. So we're going down, and this is the period, so down and up and back down. So, yep. Oh, look at my little sign. So cute. Okay. I guess it's cosecant. And they want 2 periods, so there it is. That's so tiny. Okay. Anyway, so there it is. And it would just keep going. It would be great. All right. And then I need to describe it. Okay, so what is it going to do? Transformations, lots of things. Horizontally compress. So the period, is 2 instead of 2 pi, which of course 2 pi instead of 2 is 6 point something. 6.28. So clearly if it used to be 6 and now it's 2-ish, it's going to compress it. So squish. All right, maybe. Any questions on graphing? Because yikes. Okay. So the idea, of course, in this is that you would actually be writing number 57 and you would have your graph, and then you'd write number 60, have your graph and description, so that you could turn that in when we are done with this. All right, so, yep, all right. State the amplitude, period, phase shift, domain, and range for each. Wow, that's a lot of things. Okay. So I'm gonna type that because that's a lot of things. All right, so for number 61, we've got 2 sine of 3x. Okay, so the period, we need amplitude. Amplitude is 2. It used to be 1, but now it's 2, so it's apparently vertically stretched. Its period used to be 2 pi, but now it's 2 pi over 3. So we'll just write that. 2/3 pi. The phase shift is none, meaning it's not shifting right or left. So that's nice. And then our domain, well, for sine, used to be all real numbers, and now that I've made it taller and happen more often, it's still going to be all real numbers. So yay. Which of course is that fancy R. So if you have the ability to do the fancy R, which is actually supposed to be bold. So isn't that exciting? Because now I can do bold as I'm typing. And range is going to be How far up and down? Ooh, -2 to 2. So -2 is less than y is less than 2. And of course, since it's actually at those, I'm going to underline them because they're actually equal to 2 there. Yeah, so again, this 2 tells us that the amplitude changes, and this 3 talks about our period. So that's where those come from. All right. And then the next one is 3. So our amplitude, is going to be 1.5. And then our period is, oh God, lots of things happening. 2 pi over 2, so pi. The phase shift, that's what's happening with this minus pi over 4. And of course it's in Funky Town, so that means that its phase shift is pi over 4, meaning it will shift right, pi over 4. So instead of going up at 0, 0, it's going to go up starting at pi over 4. Okay. And then what else is left? Domain. Hey, it's still signed, so it's all real numbers. Oops, I don't know what I'm doing. Oh, bold, capital. I was mixing up the shift and the command button. Okay. And then the range is going to be based on our A value out the way out front here. So it's going to be, holy camole, someone just dropped a laundry basket down the stairs. It sounded like someone was dying. Okay. All right. Alrighty. My 3-year-old is into throwing things right now. He literally threw a stool at my mother this morning. I don't know what's happening. I have a terror child. Because he didn't want her to help him with his snow pants. Okay. Okay. Anyway, so the amplitude is 4. Super. Just hearing a lot of noises right now. Because of the 4 way out front. Your period is 2 pi over 2. So now it's just pi. Yep, still both of them have a 2. The phase shift is really annoying because it's a whole number, but either way, phase shift, I'm not having to graph by hand, so it's fine, is 1. And so that means it's shifting your cosine, which would normally be at 0, 1. It's making it shift to the right 1 unit. And the domain is all real numbers because that's what it is every time. Let's see. And then the range is, because of 4. Oops. -4 to 4. And so we'll underline that because it equals 4. It's very exciting. Oh, there it is. All right. And again, those are all based on, all these numbers in here. So 4 for your amplitude. Pi comes from the fact that there's a 2, and the -1 is here. All righty. We're going to use a calculator. Ooh, okay. So literally just type this in. That's not so bad. So sine inverse of 0.766. And of course, the button is second of sine. Oh, I wonder if I should round that. In degrees and radians? Oh. Use a calculator. Okay, fine. So it's 49.9960, and I am in degree mode, so that's degrees. And then your radians is going to be 0.87. Usually if they don't have a whole number, it's dumb to do radians, but whatever. Okay. Call them rads. Okay. Then this next one, cosine inverse in degree mode, is of 0.479 is 61.3799 degrees, or if we change our mode, we're going to get 1.0713 rads. Okay, tangent inverse of 1. Ooh. Tangent inverse of 1, boop, boop, is 45. And 45 in radians is actually something we can do, so pi over 4. And again, you can check on here, 45, pi over 4. Or you can convert them. And then sine inverse of pi over a square root of 3 over 2. It does say use a calculator, so we'll just do that. And what mode am I in? Degree, okay. 60 degrees, oh, so exciting. Basically, it's just asking at what degree or radian is sine or the y value square root of 3 over 2. And then 60 degrees is pi over 6. There it is. All right. But of course, it's a decimal if you really wanted that. The next one, they want you to find the exact value. Okay. So we want at what degree, or, oh, this is radians, but whatever, at what degree is sine a half? So where is the y value a half? So going over here, the y value is a half here and here. So then you look at the second part of the phrase, which says that it's going to be in quadrant pi over 2 to pi 2. So if we go to quadrant 2, it's this guy between pi over 2 and pi. So that means that this is our answer, 150 degrees or 5 pi over 6. And of course, it just depends on if you want to do radians or degrees, but there you go. The next one, we're trying to find out at what degree are we going to get a -1 for our tangent. So again, going back here, -1 for tangent. That means that sine and cosine are one of them negative. So here and here, because they would make a fraction of -1 if they were put together. So we're either doing 135 or 315, but notice that it says that it's going to be between 0 and pi, meaning in quadrant 1 or 2. So the answer is going to be that we are up on here, and so that means 135 or 3 pi over 4. All right, sweet. This next one is cosecant, which is 1 over sine. So they're trying to get us to find out, I apparently changed it to theta, when will it be 1 over -1? So when will sine be -1? And sine is -1, where? Sine is the y value, -1 over here. And if we go back to what it's saying it needs to be within a unit circle. Oh, well, thank you. Okay, so quadrants 1 through 4. So it only happens once anyway, so it's down there at 270 degrees or 3 pi over 2. Hopefully clicking through all these pages isn't giving us issues, but all right. So questions on these guys? This is kind of just giving you where, or it's telling you which one of the answers that you chose is going to be the right one. Because this usually gives you multiple choices as your answer, and so you just have to refine them with this phrase. All right, evaluate the expression without a calculator. Okay, sounds good. So we need tangent inverse of 1. Did we just do that? Because it's always nice to just repeat things. Ha, we did. It's 45 or pi over 4, so I'm going to cheat. All right. So pi over 4, and so now we just need what is tangent at pi over 4. Hey, all right. So going over to pi over 4, tangent is the y value over the x value, right? Sine over cosine. So that's going to be 1 in this one. So a bunch of stuff to just get back to the number 1. Which honestly, if I had looked at it closer, it totally makes sense because we did the tangent of the tangent inverse, so they should cancel each other. So 1 is our answer. Oh my god, that's what's happening here too. Cosine inverse of cosine, so just pi over 3. Answer. And same thing happening here. My god, I love it. Okay. Well, that was hard. Not. Okay. So then we need to find the length of the arc. So looking at our formula, arc length, yeah, depending on if you have radians or degrees, is going to be here. So they gave us radians, which is nice because that means that the arc length, which is s for some reason, is r theta, meaning theta is 2 pi over 3, and a radius is r. So our arc length is 2 times 2 pi over 3. So 4 pi over 3. Yep, that's it. Woohoo! A tree casts a shadow of 51 feet long when the angle of elevation of the sun. What? A tree casts a when the angle of I'm gonna do the tree, okay, and its shadow is 51 feet long. Whatever that number is, there, 51. Angle of elevation with the sun measured with the horizon is 25 degrees. I assume that means this angle. Yeah, angle of elevation, because angle of depression would be down. So angle of elevation, boop, boop, is 25 degrees. I was thinking of putting it here, which is still where the sun is, but not helpful when it comes to actually solving the problem that there's 51 feet for a shadow. Okay, so they want to know how tall is the tree. Who wouldn't? Okay. So how tall is the tree? Well, it's the opposite side of this angle that we're talking about. The shadow is the adjacent side, and so therefore we are talking about tangents with SOHCAHTOA. We have O and A, and that means that we're going to do tangent of 25 equals opposite over adjacent. So knowing how to set that up happened in geometry. It was very exciting. And now knowing how to solve it, you got to multiply it across. So tangent of 25 times 51, or just know how to solve that it used to be dividing, and so you should now multiply. But anyway, we're going to multiply. You also want to make sure you're in degree mode because we were just switching around before. So make sure you're in degree mode since you're entering in degrees. And so 23.78. I remember my pre-calc teacher, or I don't know, whenever I was talking about it. Feet. Didn't really clarify what mode I was supposed to be in, except by just being like, hey, degree mode. So if you're ever inputting degrees or you want degrees out, you need to be in degree mode. If you ever are inputting radians and want radians out, then you go in radian mode. Most of the time you want degree mode unless you're graphing, and then you want radians because it won't fit with degrees. All right, and our last question, right? Yeah. From the top of a 150-foot building, Flora is observing some stuff. Okay. So be careful, Flora. Here. A car moving towards her. Oh, okay. Here. And then there's the speedy lines. Okay. All right, so the car is moving towards her. If the angle of depression of the car changes from 18 to 42 degrees. So this is where angle of depression is really obnoxious because it's actually this way versus, what am I thinking? This way? You feel like it should be that way, but it's not because it's always with the horizon. Okay. So moving on, draw the horizon line first and then talk about where you're going. And so this one used to be 18 degrees and now it's 24 degrees because the car is now moving towards her. So let's see, how can I draw that without messing it up so much? Let me think about how I've messed this up here. Because it's supposed to be like that. Oh, okay. Here. Okay. So that's there, and then the car moves closer. But to get those ones, you had to do this. So I was right. Okay. So with the first one, this measurement is 18. But with the second one, this measurement is, what did it say, 42. Okay. Whew. That took me a while. Okay. So during the observation, how far does the car travel? So we want to know this distance here, which is going to be the part of the, what is it called, right triangle. So we're going to use some trig. So we have according to where these angles are, it's much easier if we look at them down here. So if this is 18 degrees and this is parallel to this, and this is its transversal, oh my gosh, 18 is here as well. So there it is. And if this is parallel to this and this is its transversal to make this 42, then that's 42 as well. Okay. So now I'm going to find the length of this opposite side when it's 18 and then also when it's 42 and subtract them. And this is the adjacent side. And as much as we love hypotenuse, it's not there. So opposite and adjacent means tangent, which means that I'm going to solve when is tangent of 18 equal to my opposite, 150. Oh, sorry, this is the opposite now that my angle is over here. I was doing it for this person. Opposite is 150 and adjacent is we don't know. And then the other one is tangent of 42 when the opposite is 150 and the adjacent is we don't know. So if we solve this, again, I solve them via proportions, but you can solve them however you want. I'm going to multiply this set of numbers and then I will divide by this one. So 150 divided by tangent of 18 in degree mode, because 18 is in degrees, so for inputting degrees, we need to have it in degree mode. So 461.652, lots of numbers, okay? And then the other one, again, same idea, we're multiplying diagonally. So multiplying 150 times 1 and dividing by tangent of 42. So if we do that, there's 166.5919. And so we just subtract them. And that's the distance that the car has traveled. So 461.6523. Oh, 25. Minus the other guy is 295.0606 feet. Woohoo. That it's traveled. Clearly not to scale. Okay. All right. So that's that. Oh my gosh. Wow, we're done with the second half of the review for a test that I will post tomorrow. So